Hello, welcome to the next video. We have finished with the related theory part for relation and functions from class 11. Right now, today I am going to discuss only the problems from the book directly. So I'll be taking the problems and I'll not write the question, but I'll show you in the video clips by showing those particular questions which I am doing. Alright. So without much delay, let us start with this. I am starting with exercise 2.3 and I am taking the vital questions, those questions which you can do easily. I am not picking up those questions, it is irrelevant, right? So I am taking question number 2 of exercise 2.3, right? NCERT book. That is, find the domain and range of the following functions. The first function is f of x equal to minus of mod x. We'll start with this, okay? So I'll write from here first, then I can go there, so you can easily keep both the sides together. So question number 2 of NCERT, right? 2, it is part 1. Your function is fx equal to minus of mod x. F of x equal to minus of mod x. You have to find the range, you have to find the domain of this. I'd like to go for this. Little time will take, other functions does not take much time. Domain means those values where I can find fx finitely, right? That means if I give x as input, my output should be finite. That only I have to take care, and for what x it is, right? So you can see clearly, I can write, because I know now more about modulus x. So you can write clearly, modulus x is defined for all x belongs to real number, right? Modulus x is defined for every real number. If modulus x is defined, then very obviously if I can put a minus sign, there is no problem, you can easily identify. So this is also defined, right? This is also defined for all x belongs to R. Defined means I can find it finitely. Now that is, what is modulus of x? Fx. Fx is defined for all x belongs to R. Now you see the last statement. Fx is defined for all x belonging to R. That means for every real number fx can be found, meaning domain is the set of real numbers, right? So directly convert. Therefore, domain of the function is set of real number. So we have found what is the domain of the function, right? Now let us try to find what is the range, right? So you see, just let me again take half a minute to explain. If the function is easy, or we can find the range by making observations, then we do not go for that lambda process, right? That considering y in the range, then finding x, like this, what I explained in the last video. But if the function is complicated, then only we will go for that, right? So here this we can do by inspection, that means by observation. So how we'll do it, you see. So we'll be proceeding it like this, right? Very clearly, for all x belongs to real number, this is domain actually, right? So if I pick, I'll draw a figure for you so that you can understand. This is the domain, which is the set of real number. This is the codomain, right? I have to find where will that fx lie. So if I put x here, how it becomes in the codomain? It becomes minus of mod x. Now make an observation. Mod x is always positive and or 0, that is non-negative. So if you put a minus sign in front of a positive number, it becomes negative. If you put minus sign in front of a 0, it becomes 0. That means the right hand side you are going to obtain either negative real numbers or 0. That's the range, right? So we'll be writing it like this. So how you write? You just try to observe it. So for all x, like this I can say is greater than or equal to 0, right? Either 0 or positive. If I put a minus sign, what inequality will be reversed, right? It will be either negative or it will be 0. Fine. Then what I can say, fx is less than 0 or equal to less than or equal to 0. What does that mean? Means if you give x as input, fx is the output. This is either 0 or less than 0. So now if you look at the real number line, if 0 is here, 0 or less than 0 is this side. That means from minus infinity to 0 is the range. So we will write it like this, right? Therefore, range of f will be minus infinity to 0. So that's all, right? This is the first question we did. In fact, I'll be doing the second question also. Second is fx equal to root over 9 minus x square. See, I'm not giving more time here. I'm just continuously doing because I have to cover more number of problems. So if you find that I'm expanding in speed, right, you replay the video once more time, you see the things and get it clear, right? Okay, so now I'm starting with number 2, that is f of x equal to root over 9 minus x square. Fx equal to, here question number 2, the function is fx equal to root over 9 minus x square. Fx equal to root over 9 minus x square. Now I have to find the domain of this first. Domain means, again you try to think. If you remember, I explained about the square root. Square root will be defined if the quantity under the root will be either 0 or positive, right? That's the funda we'll be using here. So we'll use this, right? So we'll be writing here what? Clearly, fx is defined, right, if 9 minus x square is positive or greater than or equal to 0, right? So this will tell you what, like this, we'll be writing it like this. Now here I have to speak a very important part, because after that students commit a mistake. What mistake they do? First I'll write the mistake so that you can remember that. The usual mistake the students do is, immediately I'm doing here the wrong thing, right? I'm doing here the wrong thing. They write this less than or equal to plus or minus 3. Remember, this is absolutely incorrect. It's not correct. It is not correct, right? What will be then, right? So once you write, it will be mod of x less than or equal to 3. Mod of x is less than or equal to plus 3. Definitely I'll explain these things how it comes, but not at this moment. Now just remember it. If you are taking the square, when inequality is there, square root if you take, inequality is there, and it will be like this. And this will tell you what? Right? This will tell you what? See, mod x is less than or equal to 3. Right? Just go for the number line, then you will easily understand it. I have 0 here, 3 here, minus 3 here. Modulus x is less than minus 3. That means numerical value of the number should be less than 3. So it can be from 0 to 3, any number. Will it be from minus 3 to 0 also? Right? Because if you consider minus 2, what will happen? Modulus will be 2, which is less than 2, less than 3. So that means once you write it like this, then the next phase is what? X will be lying between minus 3 and 3. If it will be strict inequality, that means equality will not be there. Here also will not count the equality. If it is there, here also you have to count it, right? So from here you have seen that x is lying between minus 3 to 3. Now what will be the domain? Right? So already you have decided what will be the domain now. You write the domain. Therefore, domain equal to, domain of f will be equal to minus 3 to 3. Minus 3 to 3. Right? That's it. Now we will come for the range. very very important part. This time we will not be doing it by inspection. We have to do it by extensive explanation what we did last day. So you see, for that I'll draw a figure. Always you draw this. This is helpful for you. What exactly you have to find? If here is the range, I'll pick one element y, and then I'll try to look for x. Right? And with the help of this x, I'll study what type of y I get. And that will tell me what is the range. So without much delay, let's start. So we'll write for the other part. Let y belongs to range be arbitrary. Arbitrary means any randomly chosen element. Then there must exist. Then there must exist some x belongs to domain such that f of x equal to y. What is this giving you? 9 minus x square is equal to y. Then after that, what was the target? Once you arrive up to this, your target is to express x in terms of y, right? So you take the square, then you find what is x. It is 9 minus y square. Then what is x? 9 minus y square. There will be a plus or minus sign when I take the square root. You will not take only the positive square root. The reason, what is the reason? The reason is very clear. Because x can take some negative values as well. So if you write only positive values, it will give you only the positive values, which will be wrong. So we have come up to this. Okay. Till now we haven't got our range. Remember it. We have got only the domain. I have to now exclusively find what is y. Now decision moment again. See, x is here means what? Gross observation. X is a real number. So x is a real number. So obviously this whole expression should be also real. Gross observation. It is between -3 and 3. Afterwards we'll think. But the bigger observation is what? That this must be real. This quantity right hand side must be real. Plus or minus, forget about that. But real. So if this is to be real, 9 minus y square should be also positive or equal to 0. It cannot be negative. So that is what now you have to write, right? So what I can write, since x is real, presently we will not talk about the range, not needed right at this moment. Real, x is real, therefore 9 minus y square must be greater than or equal to 0. So now you see, you are arriving exactly at the same equation what you got for domain, right? It was x that time. So this time you can directly do this. So y square is less than or equal to 9. That gives you mod of y less than or equal to 3. That gives you y lying between -3 and 3. That means y is belonging to -3 to 3. Close interval. That's it. You got the range, right? So this is the range of the function, because y means the elements in the range, right? Can you remember something now? When I was explaining the range, that time I told you, immediately do not come to the conclusion after coming here. You have one more step to be done. What is that? Go back to the original function and see what was the nature of fx, because fx is y. Fx is only y. Here we have written fx is y, right? So I have to talk about the nature of that also. What was fx standing for? It was root over 9 minus x square. It was plus or minus. What is the sign preceding this? Plus. But here this is coming in a range of -3 to +3. That means some negative numbers are there. But definition of function says fx is not negative. So very definitely combining this and that condition, now you come to the conclusion. If it is not negative, then its value should start from 0. not from minus 3, right? So that is a very important observations to be made, right? So here I will be writing there, but fx, that is y, is non-negative, right? Non-negative from where we got? By definition. Definition means where it is told fx equal to root over 9 minus x square, right? So we got this. So if it is non-negative, what will be your answer? What will be your answer? Just directly write in. Therefore, y must be belonging to 0 to 3, and therefore this is the range of the function. This is the range, right? So be very, very precise to this particular point. You don't worry about this, you'll be immediately getting one collection of problems. There is class note, not for this video. The last video I did not upload it. I'm going to tag it very shortly. You please download the questions and do this similar questions again. Okay, so we have finished with this. Now I'll be taking the question number 5, where they are asking only to find the range of the functions where domains are already given, right? So I'm picking up those questions directly, immediately, without much delay. Question number 5. It is find the range of the following functions. The first function is fx equal to 2 minus 3x. X is a real number greater than 0, right? So question number 5. Number 1. Your function is given as fx equal to 2 minus 3x, where x is a real number and it is greater than 0. Greater than 0 means positive. 0 is not included. Negative numbers to cut. So now you have to find a range. Domain already done, right? Domain is this given only, right? So now let us try to find the range. Idea is same. I'll pick y from the range and trying to find x. Let y belongs to range be arbitrary. Then there must exist some x belongs to domain such that fx equal to y. Make sure to write like this. Then what was the target? You have to find what is x. So x will be what? 2 minus y divided by 3. So this is the part from where you can make now observations. Because you know about x. What type of x? Real number, gross observation. More minute, positive, right? Now you see. First of all, first check. Is there any possibility that for any value of y it can be not real? No, it is not, because y is in the numerator only, not in the denominator. Had it been in the denominator, I could have told that value you exclude, for which denominator becomes 0. But there is no question of denominator to be 0, because it is a constant 3. Come to the next. X to be positive. X to be positive. This quantity has to be positive, meaning this has to be also positive. Now you tell 3 is already positive. So whole quantity will be positive when? If the numerator is positive. That's it. Right? So we have to do that. So our observation is this, and we are now going to conclude. Since x is real and x is positive, right? Therefore, very clearly you can write this quantity should be also positive, because this was x. Now this is not negative, it is positive. So to become completely positive, this has to be positive, right? So what will get y less than 2. Y less than 2. Now in the number line, immediately you try to see it is 2 here. Less than means this side, and it will be an open ball, right? What does it mean? 2 is not to be included. So you are running from infinity till 2, but you are not reaching 2. So what I can write? Y belongs to minus infinity to 2 open interval. And that's it. That's the range. That's the range, right? So this is an easy problem, polynomials. Right? So I'll come to the next question now. A few questions I'm doing directly, not giving you to do. But anyway, you'll be getting enough number of questions to do, right, from your side, right? So now, x square plus 2, fx equal to x square plus 2, where x is a real number. Number 2 I am doing. X square plus 2, where x is a real number. X square plus 2, where x is a real number. Range I have to find. See, here we can do it by inspection without considering that y. Why? Because this observation is very, very clear. What observation will make you see? Think about that. My inputs are real number. My inputs are all real numbers. This is a term x square. Any input you give x, what do you say about x square? Can it ever be negative? Never. Can it ever be 0? Yes, it can be. When? If x is 0. Can it ever be positive? Yes, it is every time positive if you give the input which is non-zero. What did you observe? X square can take only values either 0 or positive. That's the observation we will make, and we will write the range little more easily this time. So you can write for x belonging to R, this is in the domain, x square is greater than or equal to 0. What I explained, right? Now I need to talk about fx, that means hold this quantity. So add it 2 to both the sides, right? So it will remain like this. What about this? Fx is greater than 2. This is the element which belongs to a range, right? It is the product, output. So output is greater than or equal to 2. Number line, again number line comes. 2 greater than or equal to means it is closed ball. And then you will be going this side. 2 towards infinity. Therefore range of f will be 2 onwards up to infinity. That's it, right? So this is the problem. And the last one is very easy, that I will not do. That is the identity function, you can see. Right, so that is your business. Now I'll be moving to the miscellaneous, right? Same type of problems I'll be picking. First let me finish with problems of range and domain, right? And then we'll be thinking about other parts. I'll be starting with question number 3 of the miscellaneous. Question number 3, miscellaneous exercise, miscellaneous. Find the domain. They are asking here to find the domain only. Fx equal to x square plus twice x plus 1, then divide by x square minus 8x plus 2. So if function is this, they are asking you to find the domain. Just you see, I am moving little faster today, right? So this is the function whose domain you have to find. Domain, remember it, not range. Domain you have to find. Domain means, again you try to see, domain means those value where the function is defined. Matlab, where the function will be having a finite real number as its value. It can be infinite. A fraction, that also I discussed. A fraction is defined when, if the denominator, जो नीचे है, should not be equal to 0. Numerator, whatever it is, right? Infinity will not be accepted as a numerator. Now you tell. Here, to get fx finitely, what is the minimum condition to be satisfied? Denominator should not be 0. That's it. That gives you the domain, right? So you'll be writing like this. Clearly, there is an irony. Let me try to share. Even if we are not clear, we write clearly, right? So clearly, fx is defined, right? Fx is defined if x square minus 8x plus 12 is not equal to 0. Okay, go for its factorization. So can you do the midterm factorization? Class 11 student, you can directly do it. So I will not show that. So x minus 2, x minus 6. Had it been equal to 0, I would have said x equal to 2 or x equal to 6. It is not equal to 0. Means x cannot be equal to 2, x cannot be equal to 6. So x is not equal to 2, x is not equal to 6. What did you observe? You will find this function not defined, means the function will not have any finite value if x equal to 2 and y equal x equal to 6 will be there. They will have finite value defined if these are happening. Matlab, if you remove from the real number 2 and 6, you are definitely getting a finite value for the function. So that's the domain. Therefore, domain of f will be complete real number excluding 2, 6. Right? That's it. So go through it. Question number 4. 4 questions already I did. Question number 4 I have done, if you remember. 4 in the sense similar to this question. Question number 5 is modulus question, which is similar to question number 3.1 what I did 2.1 today first time. So I am excluding 4 and 5 for you as a homework. Come to question number 6. This is a very important question because of the representation, because this is a representation in set builder method, right? So you have to find here the range, right? I am writing the function. Question number 6. Here the function given is, in the set builder method they have told is x square divided by 1 plus x square such that x belongs to R. Such that x belongs to R. That means you are told to pick x from the real number. That means domain is real number. Right? Now you try to see how we'll convert this into the conventional way of writing the function. Just try to remember what this particular ordered pairs tells you. Right? When we studied relation, we wrote it x comma y. Then we write the criteria for y, or what is the expression for y. I told you that time also that we can write it in a short or in a stylish way. This is what, instead of writing y equal to this big expression, we directly write the value of y here. What does that mean? Y is this. That means fx is this, because y and fx are same. So I can write, therefore f of x equal to x square divided by 1 plus x square for all real numbers. So now I am confident I got the function's conventional expressions. Now I have to talk about the range, because domain is very clear. Range means you have to talk about the value of y, that is fx, where it lies. Okay. Now you see, we can proceed by the conventional way of finding the range. That is okay, well and good. But after doing, after once I do this, you will also be feeling that it should be done by inspection. Inspection is easier in comparison to the other method here, if it is possible to apply, right? So I'm doing it here. So you see, you will also find it very easy. Inspection I am doing because you see both the quantities are positive, power is even, there is very less thing to explain. That's the advantage actually. So what will write, you see, for x belongs to R. Why x belongs to R? Remember, it should be taken always from the domain. Always from the domain. Had it not been R, I would have written as x belongs to domain, right? As it is directly R, I am writing R, a real number. For this, what can you observe for this? X square will be positive, or it may be 0, greater than or equal to 0. We already discussed, so I will not take much time for that. Fine. Secondly, if immediately after this I add 1 to both the sides, actually I am targeting this part now. So if I add 1 to both the sides, we'll be getting this, adding 1 to both the sides, and this one is strictly greater than 0. So what will be this particular statement implies? 1 plus x square is strictly greater than 0. Strictly greater than 0 means positive. It is not 0, right? Positive and non-negative are different. Non-negative will include 0. That means this is non-negative, but this is positive, right? Now you can make a observation. Therefore, what can you talk about this? Quantity above is non-negative, means maybe 0, maybe positive. Quantity below is 100% positive. Two options. If both are positive, whole fraction is positive. If numerator is 0, whole fraction will be 0. So ultimately combining these two, what you can say? This will be either 0 or greater than 0, right? That means fx is greater than or equal to 0. This is one of the part, remember it, one more part is there. Now how will you come to know that there is one part? I already told you, there is no like a fix or thumb rule that you will come to know that for this I have to do other part, for that I did not complete. It's not like that. Once you go on doing the problems, you will automatically gaining the intuitions, right? That's what the beauty of functions, right? So this is one of the part. Okay, now next, also if I ask you to compare this quantity, one is 1 plus x square, another is x square, what your logical mind says? Is it not bigger than this? Right? Is it not bigger than this? Yes, obviously, because see, this is x square, always positive. This is x square, apart from that one more extra. Right? If I say like that, whatever amount of money you have, I have 1 rupee more than that. So my money, my amount of money will be always bigger than you, no matter how much money you bear. Right? If you bear 10 rupees, I will be having 11 rupees. If you bear 10 crore rupees, I'll be having 10 crore 1, still I am having more than that. So logic says this is bigger than this, right? Because both are positive here, equal. So this is strictly bigger, remember it's strictly bigger. Equality will not come here. Okay, very nice. Now immediately after that you let me know what do you say about this? What do you say about this? See, this quantity is always less than this. You find a fraction, numerator is less than the denominator. You find a fraction, numerator is less than the denominator. A proper fraction. Proper fraction is always less than 1. So, what you will get? Fx less than 1. This is say star s. Now I am at a stage where I can conclude the final range, right? How? See, combine those two, right? I am just drawing the number line and just comparing this. It is always helpful if you draw the number line. One is 0 here, another is 1. First one says fx is greater than or equal to 0. That means 0 will be included and you can go this side. This is about the stars conclusion. Okay. Second conclusion is less than 1, strictly less than 1. Means this will not be considered. Otherwise you can come to the left side. Now both star and star dash together should occur because I am talking about the same expression with the same element in the domain. Both should be satisfied. Both will be satisfied in the common part. What is the common part line? 0 up to 1 but not 1 because it is open. Here it is closed. It will be included. So you can write, therefore star and star dash implies fx belongs to, rather I'll write first in the interval format, that is less than or equal etc. Then you will be able to understand this better. it is like this, that is Ax belongs to 0 to 1 open interval, right? And that's the final answer. Therefore range is, never forget to write the conclusion, right? In this kind of maths for relation functions, actually this belongs to the pure group of maths. So pure maths needs extensive logical reasoning and a very formal answer, remember it. So that's it, that's the required range. This is an important question, please mind it. Okay, now I'll be taking the another problem. Here question number 8. Question number 8. If I will be left out with time, I'll take 7. But presently question number 8. You are given the function f in the roster method. Right? Question number 8 of miscellaneous. I'll write this. There are 4 ordered pairs like this. Right? And you have to find what is the value of a and b. I'll do that. Ordered pairs are 1, 1, 2, 3, 1, 1, 2, 3, and then 0, minus 1, and then minus 1, minus 3. Okay, so this is the function given to you, right? This is a function from z to z, and this is the roster expression, right? Functions expression in roster method. Then we have to find a and b if fx equal to ax plus b. We have to find the value of a and b, right? So here we'll write that also. Here f of x is given as ax plus b, where a and b are real numbers, sorry, integers, right? So I have to find those two. Fine, very fine. Now I have to find a and b. Just try to remember relations, because we'll borrow some of the concepts. Relation is in a broader sense and it is having a part function, right? If I talk about an element like this, what does that indicate? Can you remember? This element is the input and this element is the output. Means this is the value of x, this is the value of fx. So if I put 1 here, this whole thing should be 1. So I'll be taking the help of these ordered pairs to find equations relating a and b. But which ordered pairs you will take? Question is that. No question. You take any, no problem. All are valid. But see, again I'll try to tell you, we'll try to do the problems in short always. So we always look for the easy parts to express the question, right? Very nice. How will you proceed? You will take this. Why? You just see what will be the advantage, right? Since 0 minus 1 belongs to f, what will it give you? F of 0 is equal to minus 1. Image of 0 under f is minus 1. So I can write f of 0 equal to minus 1. So I think this is very clear. We explained it. I want to use this definition. If f of x equal to ax plus b, f of 0 will be what? A times 0 plus b equal to minus 1. So what will you get? This becomes absolutely 0. So b equal to minus 1. So this is the advantage we already foresee. Right? If I have a 0 here, see, directly you get the value of b. Right? If you would have started with any other ordered pairs, you would be left out with relations of a and b. So definitely there will be needing another relations to work on, right? But there is no harm about that. You can do it. We got the value of b. Fine. Now what is left out? We need to find what is a. So pick up any one of the ordered pairs which you feel to be convenient. My sense say that this is little easier because these are having bigger numbers, right? So we say also 1 comma what belongs to this. This implies here, right? So f of 1 is a plus 1 b equal to 1. Value of b is already known to you. It is minus 1. So at that time, if you transfer that minus 1 to the right side, it will be plus 1. So a equal to 2. Therefore, sorry, I was about to conclude, but I want to ask you a very small question. Should I conclude now only? Should we be so quick to answer? No. This is a very important part. My children, be very, very alert about it. You have worked on only 2 of the ordered pairs. What is the guarantee that if you would have worked with these 2, that would have generated the same answers what you got presently? Okay, I say that you can take any 2 of the ordered pairs. I said formally we can do it. But what is the guarantee? So now you have to guarantee also that if you solve for the other 2 pairs, that is going to give you the same result. How will you get it? Simple. You need not solve it again. Simple you have to do. Find the image of 2 under this map using this value and see whether it is 3 or not. Find the image of minus 1. See whether it is minus 3 or not. If it is, you are correct, right? So that's what now we have to verify. You need not write that we are going to do the verification. Simply you write now f of 2. F of 2 will be equal to a into 2, then b. Now put the values. This will be putting 2, so 4, then minus 1, 3. That is 2 comma 3 belongs to f, which is true, which is true. So which is true. I am just observing the board whether it is being recorded or not. No, last step is not recorded. So I have to write this, rewrite this. Okay, I have to rewrite this. What I'll write, I remove this. I am going to write it at the top. So after that, what I should write? Therefore, 2 comma 3 belongs to f, which is 2. One part is done. Now other part also. F of minus 1 into a minus 1 plus b is the function. This is the value of x. A is 2, so it will be minus 2. This is minus 1, giving you minus 3. So what does that again generate? Great. So you can again think about conclusion. So what you can write? Therefore, minus 1 minus 3 belongs to f, which is again true. Which is true. That means the values you opened or you found out for a and b are not going to contradict the whole results. Therefore, the values of a and b are respectively 2 and minus 1. Please make it sure to conclude at the last. I am not writing these conclusions, right? So that's the values. Now 9 and 10 I am leaving for you, right? I am coming to again question number 11. 11 of the exercise. That is again I am saying you that it is a very important problem. What is given here? I will write the relation. I will not write the complete questions here. I will be taking it in the video, no problem. Or else you can keep the book with you while studying. Let f be a subset of z cross z. Z cross z is a Cartesian product. Every subset of it is a relation. So I could have told you like f be a relation on z to z, right? On z to z. It's defined as f equal to this question number 11. Here f equal to, how did they define? AB comma a plus b, where this a and b are both taken from z. Z means set of integers. Is this a function from z to z? Justify your answer. Justify your answer. what do you say? What is the criteria to think whether this is a function or not? What we should see? Remember the definition. Definition says function is a rule allotting a unique value, right, to each value of the left side set. Meaning every point in the left side set of the function should have exactly one image. So now just I have to check if my input is a special value, say 5, suppose 5. Can I always get the same or only unique one value related to 5? Or I can get more value which is related to 5 with this particular relation. If I get, then it will not be a function. If I do not get, then it will be a function. Let's see. Right? I'm talking about a particular case. Remember it. Once you want to prove that it is not related to more than one, you have to prove it for all the points. Right? But actually I already know that this is not going to be a function. So I'm talking precisely about a particular point. Okay. So how we will proceed? I'm writing at the top. If directly will come for the counter examples. See, there is the advantage. I'm just giving a 2-minute example because this is going to help you immensely. If somebody says you prove something, you have to go for the general proof. By citing examples, you cannot do. Right? For example, if you ask me, let's prove that this human being is good. So it's not that I can give only some examples. Okay, he is a very good gentleman. Right? Society commands, in the society he commands respect. So he is a good person. No. You will not accept. Then you will directly say, sir, is he really a helpful person to others? I say yes. Then again you will ask me questions. Right? Does he have a good bank balance by which he can afford others persons to help? Yes, I have to say. So lot many questions you can say. You can ask, is his moral character good? Right? Is his character good? Is his health good? Does he follow the social rules? Does he follow the social norms? I have to give clean sheet to everything, then only it will be good. Right? But if at the same time I say, or you ask me, sir, is this person a good person? You tell that he is not good. Give an example. Will not that be enough? Did you get me what I am trying to say? That means to prove something wrong, only a counter example is enough. To prove something correct, a general explanation is needed. I have to prove here it is wrong. So I'll have to just look for one loophole. Right? So here the loophole. If a equal to 1, say whatever number I told, let me take those only. Right? Then it will be like related. Otherwise, you might think sir ने कुछ बोल दिया 5 but लिख दिया 6 के लिए. Right? So a equal to 5, b equal to 5. A equal to 1, b equal to 5. Then what will be ab? 1 into 5, 5. What is a plus b? 1 plus 6. 1 plus 5, 6. So now this rule you see, any two ab from integers you pick up, ab will be the first place, a plus b will be in the second place of the order pair. So I can follow that instruction to say 1 into 5, that is ab, and 6, this belongs to f. Perfect? Okay. Now do you have any other option so that product of that two number will give you 5? Think. Okay. I am writing. I take a equal to minus 1, b equal to minus 5. Then what is ab? 5. What is a plus b? Minus 6. According to the definition, what I would say, this belongs to f. That's the counter example. Ordered pairs 5, 6 tells you that 5 has a image 6. 5 has a image 6. 5 comma minus 6 tells you 5 has a image minus 6. 5 is the element here which has two different images, and you know that this is not the case for becoming a function. That's all. So you will just write now a concluding statement in order to conclude your problem. So how you write? Since, okay, I'll write little more powerful sentence, right? Powerful explanations. Clearly, 5 has two different images, right? So f cannot be a function. Why I said powerful? I was about to write this directly. No, you cite the reasons. Then you are at a stronger point in your logic. So here you see I have covered very important points already. So I'm going to take 2-3 more problems, right? Little different, and then I'll be binding up the chapters today. And then if you'll be having any problems, then you please kindly let me know, so that we can resolve your problems, right? So now I'm going to take some problems which are not directly from the book, but little different, right? Okay, so this problem I'll write completely because this is not available in the book. Question number 1, right? Extra I am writing. These are extra. So question number 1. Find the domain. First let me talk about the domain, right? Find the domain of, right? Okay, we did 9 minus x square. Now I am proposing to do x square minus 9. We have to do the find the domain of x square minus 9. We proposed to do this. We did it for x square minus 9 minus x square in the book. Many of the persons, students get confused. They feel that same answer ही आएगा, क्या फर्क पड़ता है? No, बहुत फर्क पड़ता है. See, domain. Again, idea is that you have to tell me those values of x where this expression is going to have finite value, right? Finite real number as its value. So you can write, we have a standard notation or a standard statement, right? Clearly, fx is defined. Clearly, fx is defined if x square minus 9 is greater than or equal to 0. X square minus 9 is greater than or equal to 0. Fine. You are about to find the value of x, so you have to write it like this. Again, I'd like to remind you, do not do a foolishness of taking the square root like x greater than or equal to plus or minus 3. Again, you will be wrong. That was for less than, this is for greater than. Still, if you take the square root, modulus of x will be this time greater than or equal to 3. Now you see, again I am giving you a very good number line here. 0 is here. Your number's modulus should be greater than or equal to 3. First you consider greater than 3. Any number from 0 to 3 will be always less than 3. So will its modulus be more than 3? No. That means the number should start from 3 and then you move towards, right? Any numbers between this, do you have any modulus less than 3? Sorry, greater than 3? Because the numbers here numerically are less than 3. As 2 will be coming here, minus 1, minus 2, minus 1, minus 0.5, like that. Moment you go to the left side, minus 4, minus 5, that means this side the numerical number value, bigger values are there. So what do you observe from here? your required numbers will be lying this side and this side, right? So this will imply what? X, right? X greater than 3 minus 3. Is it? That's the domain. Think. But remember, what I wrote is a rubbish thing. This is absolutely wrong. I am trying to point out those particular moments, those particular instances where students commit mistakes. Many of the students might try to write it like this. But see the logic, then you try to justify whether you have written correctly or not. X is greater than 3, fine. At the same time, X is less than minus 3. Because together you are writing means this should hold together at the same time. Now, do you have any number which is at a time greater than 3 and less than minus 3? Not possible, because they are entirely different regions, right? Okay. So you cannot write like this. Your observation should be here what? Therefore, X is less than minus 3 or X is greater than or equal to 3. Or will come, or, right? Right? So it's the answer. Now you can say this is the domain, right? And if you would like to write it in a stylish way, because you need to know the options. Stylish means I'm not talking about writing some bombastic kind of words, right? I'm talking about the various symbolizations, because it's not the only symbol by which we write the domain. We'll be having more representations. See how do we write for this, right? How do we write for this? I can write it like this. I'm using that is for all the remaining parts what I'm going to write. You can leave the answer here also, saying that this is the domain. So I can write it like this. What I can write? Minus infinity to minus 3, close interval, or stands for union, right? That is little more smarter than this, right? So you can opt for this answer. Okay, fine. Do you have any better idea for expressing this? Yes, why don't we have, right? That is, look at the number line and then you tell me, from the entire real numbers line, which particular part you have kicked from minus 3 to 3? Did you include minus 3 and 3? No. So open interval minus 3 to 3 has been kicked out from the real numbers. That's all. So you can write that is R minus 3 to 3. Right? Sorry, here I have to write one more. X belongs to. So, you please, again I am reminding you, you do not leave the answer here immediately. You have to write now. Therefore, the required domain is R minus this. Make sure to write this, because pure maths teachers are very, very logical in their answers. And whenever they find these things, logic is missing, conclusion is missing, formality is missing, even if it is a maths, we are going to deduct a mark for chapters like relation functions, right, which are pure maths chapters. So be very, very precise to write a very good statement, logical statement, powerful statements, right? So anyway, one more problem, last problem I am doing extra, and then I'll be binding up the chapters. Again, I'll be asking the domain only, right? Practice for the domain at the beginning, then you go for the range. Because range is little problematic in comparison to the domain. First, you try to tackle domain very comfortably and confidently, and once you are confident, then you do the problems of range, right? Question number 2. Question number 2. My real function is this. Fx equal to under the root x square minus 5x plus 6. Right? I have taken questions from the root only. So anyway, that's not an issue. You need to practice every problems, right? So what is the first thing should strike to your mind? If this function is to be defined, what is the first criteria which should hit your thought? It is under the root. Quantities under the root should be always non-negative. It is greater than or equal to 0. That's the answer. So you can write fx is defined if x square minus 5x plus 6 greater than or equal to 6, greater than or equal to 0. It is to be factorized. It is to be factorized. I could have shown you one more way by making or by doing completion of squares, by taking this problem exactly to the problem where we use the modulus, right? That way you try yourself. Actually I'm going to just give you a shortcut, right, which is equally acceptable in exam also. So if you factorize this, see, you all are class 11 students, so you can do the factorization directly. So I do not show you the midterm factorization steps. I got this. The shortcut I am going to tell you is valid for two such factors, right? That means for quadratic expressions which are factorable into linear factors. Factors should be in the form of x minus something, y minus something, not something minus x. So immediately after this, what you can write? You can directly write a domain. How? I'll write the answer here, but I'm showing you in a number line. This is a number line. Then you try to locate the points what will be obtained from here. One is 2, another is 3. In the number line, if you represent 2 is here, 3 is here. Now the master shortcut. If you are having greater than equal sign, you forget for the moment, that I'll tell you. If it is greater than sign, outer side is your domain, right? This is your coverage area if it is greater than, and if it is less than, by chance sometimes less than you need, then the area between 2 and 3. So here it is greater than, so area will start like this. That's the shortcut. And now come to the equality. Very simple. If equality is there, these 2 points will be included. That means closed interval will come with reference to these 2 points. And if it is strictly greater than, equality is not there, open interval. That's the case. So directly you write here, therefore x belongs to, sorry, I made a mistake here in writing this. X is not belonging to this, it is the less than 1. It belongs to minus infinity to minus 2 union minus 3 to this. So at least you write, hence the domain is this point. And again, if you want to write it in an alternative form, you can write whole real number minus open interval 2 to 3, right? So this is what I have done for you, and of course there are many more problems to be done. So my time permits this much only. So this is the last video for you all in relation and functions. We'll be starting the next chapters, that is trigonometry. So I say goodbye for this particular chapters to you, and please do practice these problems first, and put on a lot of practices on the concept of domain and range if you really want that it becomes clear to you. Okay, goodbye, all the best.